Okay, so we've done our cutting for the day, and now it's time to do a sort of, more fun sort of ongoing projects that I have in the shop. So one of the parts around that is that I need to draw a cross member for this 32 GTR I'm working on. Customer supplied a engine transmission. Transmission was held up temporarily because we had to get a factory one, but it turns out the factory one doesn't fit. I think it's because the custom adapter, bell housing combination, whatever it is, ends up being that the bolt alignment ends up being out by a whole bolt hole in an area. So what I've done is I've worked out the height the transistor sit, and I've worked out where everything needs to be, and I've put a factory rubber on here. So now I'm going to take a quick scan, draw up a cross member. I'm thinking doing it out of like 8mm aluminium, keep it light. It's got a billet oil pan on this, so it's going to look really nice with that as well. So yeah, get the scanner out, start scanning, get a card drawn, cut and folded near the jam. Let's make it happen. Okay, so I have touched it with a bit of 3D scanning spray on here just to help with the actual shiny part, so the billet parts and everything, to sort of stop that reflective sort of area giving me any false light. But with this scanner, I don't need any markers or anything to do a scan like this because it has so many features. So I'll get this done very quickly. It'll take me bugger all time. We can start the CAD process and get this sort of drawn up and in the car within sort of half a day or less. So I'm just going to quickly check what I have in stock in the way of thicker aluminium. I'm looking for a nice small remnant or something like that in 8mm or 10mm. What are you doing? What are you looking for? Well, that's 4. Well, I'm looking for aluminium. So here we go. We've got some 10mm here. And I think I've got some on this rack down here. Yeah, we have a couple of slabs. That'll be enough. So we'll draw an 8mm. Okay, so I've just finished drawing this cross member out of the 8mm aluminium that we're talking about. So obviously I've used my scan for reference of lines and fittings and everything, so I'll just put that up so you can see. So my plan is to weld inside of this, probably both sides, just do a stitch weld on both sides, just provide a whole lot of extra strength. The factory mount's actually done very well, and it's got a piece that sort of runs in the middle here. If I turn off, or if you look on the inside here, the mount, you can see just in here, the mount's actually got a hollow where it can actually run a gusset in the middle, which is pretty cool. But because I don't want to run an extra gusset in the middle, just because I want it to aesthetically look better, I've gone one of them on the outside. This whole mount should weigh less, and it fits the same amount of flushness as the bolts, so it's not going to hang any lower. It will hang the same amount of height as the studs on the cross member. So now I've got to make flat patterns, get it all drawn up with, I've got all my bend sheets and bend data done, so I know what exactly I'm doing when I'm going to bend it, and we'll get off to the laser cutter. So here I am, getting this pushed in between the jobs here to get it cut ASAP. I thought I'd quickly take you through some of the setup time that it takes to load a sheet on, to give you more of an understanding. So we use 2 beds here. I prioritise one for aluminium to keep it all clean. So one of the parts we have to do here is we have to do a nozzle change to do the diameter that's going to suit that cutting type. We have to change the gases over to suit whatever gas style it is. Here you'll see we're doing an edge find, and this detects how off skew the sheet is, so we can make sure that we are perfectly true to the work piece and we can utilise as much material as we can on that piece we have. And then as you can see, we're doing a perimeter check to make sure that we're going to be just within tolerance, to make sure that we can stay as close to the edge, once again to save you and myself in this case as much material and much cost on the product. So we'll get this cut and we'll get it folded up and on to the next step. Alrighty, so this is the cross member for the GTR that's in the background over here. We've made it out of 8mm aluminium, as you saw we cut. I've got ambitious and I've just started welding it up. I've already folded it up. You guys have seen a lot of folding, you know how it sort of works. There's not a whole lot of complex bends or anything either. So obviously we've got these side gussets here to add a whole lot of strength. All I'm going to do quickly now is actually stitch it off. I'm not going to fully weld it. It's not required. It's going to put a whole lot of heat to this thing. I don't want to move or walk around because it should fit up perfectly, because obviously we've gone through the process and scanned it and drawn it properly. I'll weld it off. Okay, we've just finished off our aluminium crossmember that I'll put in a second, but I just want to show you the factory one we're replacing. Why are we replacing it? It doesn't fit up anymore with the Turbo 400 and the conversion kit and everything that's there with the bell housing. I don't know what happened to the making, but it doesn't fit anymore, which is why we're changing it. But these were actually engineered very well. As we talked about before in the CAD portion of it, it's got this slim design here, which actually fits in between the mount, giving it a lot of strength this way, which is why we've gone for the thick 8mm. But impressively, this is still mounts for lighter, obviously, than this, obviously because it's aluminium, but this is quite beefy too, being at 8mm, the fact that it's got the side gussets on it. So let's bolt it up, make sure it fits, and show you why and how different it was than this one. Okay, so this is the factory one. As you can see, it's got a nice beefy Turbo 400 in here. So if we try to bolt this up, everyone said it should fit, but it doesn't. As you can see, if you come over closer, it's actually a full bolt hole out. I know there's a couple of different varieties of these ones. I've tried them all, it doesn't fit. So I haven't actually tried this yet, but I'm pretty confident because this is not my first rodeo when it comes to drawing things up anymore. But have a look at that. It's almost like I fluked it. Let's get some bolts in it. We'll bolt it up quickly. I don't even want to leave it home. So I end up only having N10 by 1.5 pitch bolts in my bolt drawer. It's a shame this is 1.25, so it's a fine pitch, but hey, regardless, this thing has come out looking lovely. I really do like the small little accents around things, like, you know, the gearbox here has these little humps or whatever you want to call it, the bolt holes where they are, and I've sort of recessed that around, trying to make it sort of look more OEM, more, you know, maybe like it came out of the manufacturing company when they built the adapter kit and everything like that, because that's what it's about. It's about cleaner, nice from day dot, not look like it's severely modified after the fact, even though it's obviously all been severely modified. Please let me know if you're enjoying these small little walkarounds and sort of, you know, articles around how we do this stuff here, on how, you know, you guys can sort of do it more, implement it more if you've got 3D scanning and you've got a basic version of CAD, because I really want to show you the content more that you guys want to see. So give me some feedback. Thank you very much.